Thanks, everybody. Can everybody hear me at this distance? Don't know how close I need to get to the mic here. All right. So I think that intro kind of covered most of it here, but a little bit about me. I'm Karl Fosaaen, practice director at NetSpy. I do pen testing. In the past, I've done lots of password cracking, social engineering, blogging. I'm a bit of a cloud enthusiast, and since we are in Oregon, I'm a home brewer, like to brew beer. I was actually here for HomebrewCon like 6 months ago. I don't know if anybody else was, but another fun conference that happens to be here. Thank you for being here on a Saturday afternoon with the competition of the other conferences going on here. I know Pokemon and anime might be a little bit more exciting, but we'll try and make this interesting. So my info's up here, NetSpy's GitHub. You can find a lot of the stuff I've written up at blog.netspy.com. You can find me at Twitter at kfosaaen. And I'm the old guy yelling at the cloud. So this is our outline. We're going to talk about all of this stuff, so I'm not going to stay on this slide. But we're going to get started with talking about dumping Azure data first. So why would we want to dump data from Azure? So we have a number of clients who are moving over to Azure because of a lot of reasons, but primarily, wow, everything is bumping ahead here. So primarily, a lot of our clients are starting to move over to Azure environments due to the fact that Azure Active Directory is easy to integrate with existing Active Directory environments. So things like role-based access control or billing. All of these things can be tied to Active Directory users and groups. And it's really easy to migrate to cloud infrastructure that's already tied to your Active Directory infrastructure. As attackers, this is great for us because things like season and year password combinations, we can go ahead and guess a user's password for a domain during, I don't know why this keeps jumping ahead. My timings are all messed up on here. Anyways, what I was saying is, as an attacker from an external perspective, we can go ahead and guess a password and get access to Active Directory through the Microsoft portal or through Azure. So frequently when we get those credentials during an external pen test, we like to go ahead and dump information from the Azure configuration to further our attack. So typically, normal domain users have access to the Azure portal. Most times that we run into Active Directory creds on an external pen test, those users have rights to log in. It's pretty rare that it's actually locked down to a point that regular users do not have access to the Azure portal. So we want to get access to all that information. Additionally, doing Azure infrastructure audits. We do have clients that bring us in to look at their actual Azure infrastructure and do an audit against best practices, make sure that everything is actively correctly managed and set up properly, all of that. So why can we do this? Well, the Azure management is available over the internet. It's the cloud. It's meant to be available publicly. Frequently, this is done without multi-factor authentication. Typically, for a standard Windows domain, they're not going to set up multi-factor authentication for the Azure portal if they're not locking down portal access in the first place. So we're finding lots of single-factor authentication points with the Azure portal, and it's easy to get access this way. So why do we want to automate this? Well, talking about all of the things that we want to gather, doing this by hand and going through the Azure portal website can be a little bit time-consuming, a lot of copying and pasting. We want to automate this with PowerShell, which is what we did with the MicroBurst tools. So MicroBurst is a GitHub repo that we've got the link for right up here. We'll have links for all of this stuff at the end, and I'll have the slides later. I don't know why it keeps jumping ahead to the next slide. I apologize for that. Anyways, the repository's got a handful of PowerShell scripts that we use to do Azure assessments. So here's some of the current functions. We're going to talk about these during the actual demo here, so we're not going to linger on these, but it does have a couple of module dependencies that'll prompt you for when you import the actual MicroBurst module. So you can find the code out here, but we'll have more links for that later. So a quick note on permissions. So Azure has three really important permissions level: owner, contributor, and reader. So within an Azure environment, and this is going to keep doing this because there's something weird with my timings. Within each Azure environment, you've got the environment, a subscription within that environment, and then that subscription has different services underneath that. Within that subscription, you've got these three different levels of permission. So the owner owns that subscription, and they have rights to delegate rights out to other users, start up services, basically do everything. Contributors have rights to fire up virtual machines, use different services, but they're not allowed to assign specific rights to other users. That's what the owner accounts are for. The reader roles have rights to read configurations, read information, but in general, not necessarily fire up virtual machines or anything like that. There are additional roles that you can create to allow, say, regular reader users to create virtual machines or deploy code or anything like that. Those aren't hugely important here. We actually dump out the list of all of the roles with one of the tools within MicroBurst, but they're worth looking into because sometimes there's some interesting kind of inheritance issues where you may end up getting owner-type access to something when you didn't intend to have that with some of these custom roles. But not hugely important here, but worth noting. So there's a number of different ways to dump data from Azure. There's the Azure portal, REST APIs, PowerShell Commandlets, and it might jump ahead. Yeah, there we go. I don't know why it keeps doing this, but anyways, we'll talk about the Azure portal first. Kind of mentioned this first. We log in through the web interface. That's portal.azure.com, and if it's tied to Azure Active Directory or back to a federated Active Directory domain, it's pretty easy to access with standard Windows domain credentials. But pros, it's a nice graphical interface. We can see kind of the sidebar here over on the right-hand side of the screen. It's nice to look at, but it's really hard to dump configuration information that way. So in terms of scaling, it's not easy to scale pulling information from there. The REST APIs that are available are nice structured JSON data. It's easy to make requests, easy to get data back, but setting up authentication for it, getting the actual tokens to access it, and some of the JSON data formatting is not ideal in terms of doing a lot of this at scale. So with the PowerShell Commandlets, we've got integrated auth with the Active Directory authentication libraries. So you just put in username and passwords, get a token. Really easy to operate with that. All of the data is typically returned as pipelinable objects. So if those people in the room that are not familiar with PowerShell, you have objects that you can basically export from one function to another and basically pipeline all of that data from one function to another. So let's say we want to get a list of all of the network interfaces for all of the virtual machines. Well, we could just ask Azure for a list of all of the virtual machines, pipe that virtual machine list into get interface, and basically pull out a list for each virtual machine, each of their interfaces. So we can pipeline all of this and streamline everything, which is really good for scalability. If you've got 400 virtual machines that you need to pull IP addresses for, it's really easy to do that. It's nice for data output as well. Those same objects are easy to export to CSV files or text files. The only real con is PowerShell is a little bit limited in terms of threading options. It's kind of hard to spin up a bunch of different threads, and it's hard to kind of multitask with PowerShell. It's not ideal, but the objects definitely make up for that. So hopefully this doesn't jump ahead here. All right, we'll just plan for that on every slide. No, it's something with the template. I was trying to add some of these transitions earlier today so that things would pop up one at a time, and I must have enabled something that automatically skips. So anyways, there are 3 different primary PowerShell commandlet modules that you're going to be using. The first 2, the Azure Service Management and Azure RM, are kind of the primary ones that MicroBurst uses. Those are more of the older style. The Azure Service Management is kind of the original PowerShell commandlets that you use to manage Azure infrastructure. Azure RM is the newer option for resource management. Most of the functions that we're using in MicroBurst are around Azure RM modules. AZ is the latest option. That's actually going to replace the Azure RM modules. They just announced that about a week ago. Luckily for me, pretty much everything's going to be backwards compatible with Azure RM commandlets, so I'm not going to have to rewrite everything in about 6 months. So that's nice. The last one that we included on here is MS Online. So this is for Microsoft Online Services or Office 365. Basically, if you're in a situation where you've got domain creds and you want to dump information about a domain, and you don't have access to any of the Azure commandlets or access to the Azure portal, chances are you're going to have access to Office 365. where you can then still pull information about the domain users, groups, lots of other stuff. It's pretty handy. But I'm including that on here because some of the MicroBurst stuff makes use of the MS Online Commandlets. So there is some existing tooling and research out here already. There's a tool called Azure. I actually just talked with the author about that. Talked with the author of that tool a couple of weeks ago about their tool. Doesn't quite meet the use cases for how I typically test Azure environments, but it is a good tool. It has great reporting. There's Azure AD Explorer. Haven't really used this a whole lot. A couple of the commandlets in there are old commandlets that are not compatible with the current version of Azure RM, so haven't really used that. But if the MicroBurst tools do not work for you, I'd say go check out those. They may be more focused on the things that you're specifically looking to test. So I would say that this book that I have right up here, if anybody wants to look after the talk, is kind of required reading if you're going to be doing any Azure pen testing. So it's Pen Testing Azure Applications by Matt Burrow. You can find that on No Starch. This came out right before DEF CON, I think. And it really clearly outlines a good testing process for testing Azure applications and Azure environments. Oh, that is going to drive me crazy. Sorry. I can probably fix this in about 2 seconds.
Is that Colorado?
Where's that? I don't remember. It was online. So just disabled the one thing that I enabled earlier, so we'll see if that works. Anyways, this is a great book. If you're going to be pen testing Azure a lot, then wow, that is really annoying. Sorry. All right. So if you're going to be doing lots of Azure applications or Azure environments, I definitely recommend reading this. And jumping ahead to the next slide. So let's talk about Azure services here. So there are a number of different Azure services that are out there. There are way too many to talk about today. We have relatively limited time here, but this is a rough count of the ones that we're going to talk about. Primarily, we're going to be looking at authenticated services that we can identify and unauthenticated services we can identify. So as an attacker, I want things that I can potentially attack unauthenticated. Enumerate different services without authentication, without those Active Directory domain credentials. And once we are authenticated, I want to be able to list out all of the different important Azure services that are enabled and stuff that we might be able to use for lateral movement, pivoting, anything like that. So this is kind of a rough overview of some of the ones we're going to talk about. But first things first, we'll talk about Azure Active Directory or Azure AD. And the primary things that we care about here are users and groups. Really, Azure Active Directory is just like regular Active Directory. Thank you. In most environments that we're dealing with, people are doing something called a dir sync or Active Directory sync up to Azure AD to basically sync up all of their Active Directory users and groups to Azure so that you can make use of those existing Active Directory users and groups. So within that, we want to dump out tons of information to start attacking other users in the environment. So additional recon info, including things like phone numbers. So let's say we compromise that external environment. We want to start doing phone-based social engineering to get our way into internal systems. Likewise with phishing, we can pull out email addresses from Active Directory, start phishing attacks that way. Taking a look at enrolled devices. This one's really fun because lots of Azure Active Directory environments are now allowing kind of asset management options within Azure Active Directory so you can track an asset to a specific person. So I can look up a specific domain administrator and know what the host name of their system is. So once we pivot to the internal network, we know exactly where that domain admin's computer is going to be because we already have the host name. Pretty convenient. Third-party apps. This is the last line down here as well, accessing third-party apps for practical examples. One of the things that we can pull out of Azure Active Directory is the list of integrated SSO endpoints. So things like AWS or WebEx or any like HR expensing software that you may have that's single sign-on. So where basically you go out to the website to put in your HR or expense information. That's going to be tied back to Azure Active Directory or ADFS, and we can list out all of the integrations there. So if you're on a red team assessment and need to get access to the HR payroll data, you know exactly where that URL is to access that. So that's really handy. It's a good way of showing impact or potential impact. The one thing I haven't covered on here is guest users. Azure Active Directory has a really interesting feature where you can add external domain users to your Active Directory domain. So I could go ahead and add my @netspy.com email address to another Azure Active Directory domain as a guest user. You can also apply the same types of users and groups policies to give myself, say, owner rights to the subscription and keep persistent access. Because if they're not looking at the specific guest users, well, there's persistence there, and somebody could persist access. So those are pretty handy. So storage accounts, we're going to give this 2 seconds to let it bump ahead and then jump back. But storage accounts are really the way of storing data. Within Azure, there's a number of different data types that are supported within the storage accounts, but you can think of it this way. Storage accounts start with the name, the type of data type, and then core Windows Net. So in this case, we've got a storage account named Nets by Azure. The service is any number of these names here. So let's say the blob service. This would be netsbyazure.blob.core.windows.net. Blob is kind of the unstructured data. You can think of it like S3 buckets for Azure. You can basically just put whatever data you want in there, and there's containers. You can apply policies to the different folders to give people access. I'll actually talk about that access policy in the next screenshot here. But this can also be easily misconfigured. So when you're setting up permissions for things, administrators need to give access to things to people. So, they go for the things that work. So container access is anonymous access for everybody, read access, everything. You can list out files and access any of the files that are in the container permission containers. So we frequently find that with containers that are just set up and publicly available. So if we step back one step here, what we would do is look up a storage account, try and DNS brute force for one of these storage accounts, look at the blobs, and enumerate folders from there. So let's say it's netsbyazure.blob.core.windows.net. After that, we would start guessing folder names here. We've got a script that we reference on the blog post down here that you can do anonymous blob enumeration. So what we do with that is a DNS brute force on that storage account and then try and look for specific containers after that. So we find very common names for folders or containers: test, dev, email, all sorts of just very common names. And you can basically throw, a directory attack, grab your favorite list of directories and throw that in for potential folders for the containers. If any of those have public access enabled or container access enabled, we'll then go ahead and just list out all of the publicly available files. This is kind of where we're at with the open S3 buckets from 3-4 years ago, where lots of public data was just spilling everywhere. We're seeing lots of similar problems with Azure blob security. If you're able to find a blob storage container that's fully open, chances are you're going to be able to list all of the different files and see everything that's there. So it's surprisingly common. We find config files, VHD files, which we'll talk about in the example, but they're virtual hard drive files. You can mount those in Hyper-V, and we'll show a full walkthrough and example here. It's kind of fun. But found some PII, password data. You can also use these for hosting payloads. So what we saw on the previous slide here is netsbyazure.blob.core.windows.net. The end of that is windows.net. And you can access that over HTTPS. That SSL certificate is signed by Microsoft. So this all looks pretty legitimate if you send somebody out to a windows.net website to download and run an executable or whatever file you want. So we've actually had pretty good luck with phishing engagements where the link is out to blob storage, because we can make that publicly available and host payloads out there. And if anybody's worried about but if I keep my payload out there and Microsoft will capture it, I've had copies of like Mimikatz and other like reverse tools sitting in a storage container for a year or more now. So I haven't gotten an email or any notification, hey, you might have malware up in your blog or up in your blobs. So it's worked out pretty well. So another service that we're commonly seeing used is Azure SQL. So it's Microsoft SQL up in the cloud. Azure SQL is really handy for just having your database out in the cloud if you're going to host everything out there. However, we do see cases where people just open up the firewall rules to the actual database, and it's just wide open to the internet. It's actually kind of hard to do. You have to set your IP address range that's allowed to a pretty wide range to allow it, but we've seen it. Typically in development environments where you've got a team that's separated across different time zones or different IP spaces, or might be working from different coffee shops, that kind of thing. But we've seen it where it's pretty widely open on the firewall rules, and you can access that directly with SQL Management Studio. You basically just point it at the Azure SQL database, and you can go ahead and try and log in. We've seen it set up with common dev environment problems of weak SA passwords or just weak credentials in general. We've also made use of it as a command and control platform. So you could just go ahead and use Azure SQL database tables and some PowerShell to basically send command and control, because again, we're going out to a trusted Windows domain and we're just making Microsoft SQL traffic. Sure, it's going out over the internet, but if you're an Azure shop, there's a chance that you might actually be using Azure SQL for legitimate uses. So one of my coworkers, Scott Sutherland, who put together a PowerShell toolkit called PowerUp SQL for attacking Microsoft SQL databases using PowerShell tools. He put together a really great blog post about using SQL as a C2 platform. So you can check that out on the NetSpy blog. You can also access this directly from the Microsoft Azure portal. There's a couple of different spots where you can pull credentials, which we'll talk about later on. But if you pull those connection strings and get access to the Azure SQL database, you can actually just use the direct SQL query functionality within the Microsoft portal and just query the database directly from the website. So that's also pretty handy. Oh, I mentioned that from an operational security standpoint. So if you don't want to open up firewall rules to your IP address to connect with SQL Management Studio, you can just go through the website, and then you don't have to open up any firewall rules or anything like that. You can just log in with the creds you have. So that's convenient. So in terms of passwords, there's a number of different places that passwords hide out in Azure. Primary one being key vaults. So key vaults are, as the name implies, a vault for keys. We find keys, certificates, passwords, all sorts of interesting stuff being stored in key vaults. Typically, access on that is pretty restricted. You may have to grant yourself access with any accounts that you have in order to actually pull out data from that. But if you do have an account that does have access to the key vaults, this can be really convenient for getting password data or certificate data, anything that might be handy for pivoting in the environment. Additionally, app service configurations, what I was talking about with the database connection strings. App services is basically Azure's dynamic application management platform. So if you want to deploy your web code out to a web server in Azure, you just point it at the repository for the code and say, hey, run a web server, run this code. It's really simple. You configure it with these app service configurations, which include things like deployment credentials. So where you upload the code to over either HTTPS or FTP. You can pull those deployment credentials out of what's called the publishing profile within Azure, and you can go ahead and put your own web shell up there, or run your own code on the web server, or do lots of other interesting things. So I've written the Get Azure Passwords module within MicroBurst here that will go out to the key vaults, pull that information down, app service configs, do the same thing, and also do something with automation accounts. So automation accounts are Azure's way of automating different tasks within the Azure environment, and you can configure these with specific credentials. You can also get access to these credentials relatively easily. You create a PowerShell script, upload it to a runbook within Azure, and the script is right here. We can see that we're just going to get the username for the credential, the password for the credential, and just write them out. Really simple. Like, this is super simple. But we're basically going to upload that PowerShell script up to a runbook in the environment, run it, get the credentials, and delete the automation script after the fact. So what we can see here is there's this kind of random, I think it's 12-character string right here for the PS1 runbook. What the get Azure password script does is it writes that script that we just saw to a randomly named PS1 file, uploads it, runs it, then deletes it, and then all that you see in the logs up in Azure is just this random string here, and you maybe think, well, maybe Microsoft ran something in the background, or this just seems like randomly named garbage. It's kind of hard to tell what this is. You can't pull down the PowerShell runbook after the fact. It's gone, it's already run, and it's pretty much done at that point. So it's not the most OPSEC safe, but it can be really handy if you need to get access to those automation creds. All right, so we'll see if it bounces ahead here. All right, there we go. So just a quick note on MicroBurst. It is a PowerShell toolkit. It's lots of different PowerShell files. To import all of those and make use of them, you can use the import module command and point it at the PSM1 file, and that will load up all of the available commands that we have within MicroBurst. So a couple of different command examples. We'll go through those in the demo here. But I would just recommend with most of them using the verbose flag. I like using write verbose because then you can kind of see what's going on, otherwise not outputting a whole lot of the data there. But with all of these, I think we'll have examples, so we'll just go through those. So getting into our demo here, just making sure we're good on time here. All right, so this is going to be a sample escalation from anonymous access. Basically, you don't see anything. We're starting with no credentials. We're going to find an anonymously available blob, download that file, and then kind of pivot from there. You're going to see all of this. This is more so if anybody wants to see the slides later and go through these. The videos aren't going to be up on SlideShare, so this is kind of the rundown of that. So this video should autoplay here. It probably won't because I got rid of the timings. There we go. All right. So what we're doing here is using the invoke. Oh, wow, that did it again. All right. Invoke, enumerate Azure blobs with the base of MicroBurst. So it found a storage account called microburst.blob.core.windows.net, and it's going to find a test container within there. And within that container, we've got a public VHD file. So VHDs are virtual hard disks. This is basically the file format that Microsoft uses for these virtual hard drives that you run virtual machines in Azure with. These are great. They're very portable. You can store them in different storage accounts, different areas. You can create them as kind of gold images. This is frequently what we see with these VHD files is somebody's created a gold image that they want to build all of their Azure virtual machines off of. Then they make it publicly available within a container, and then we download it and get access to it. If you want to play around with this yourself, I would recommend using the small disk, all one word, small disk images for, say, Windows, because those are only, I think those are 32 gigs compared to the standard 120 gig Azure virtual machines. It's a lot easier to download 32 gigs from a VHD file than it is 120. So if you're going to play around with these and do this yourself, I would recommend using those. I will also say, all of this is done in videos. I initially recorded these for DerbyCon a few weeks ago. I've burned this entire environment down to the ground because I figured, well, if I'm instructing people on how to attack my Azure sample domain up here, probably need to get rid of that after I make all of this stuff public. So, yeah, I think that covers that. So, let's see if we can bypass that jump there. So what we're going to do here is paste the URL that we just saw in the last script there. Now, I'm not going to make you wait and watch 32 gigs download here, so we're going to fast forward in time. And there's our test VHD file. So if you right-click and mount within Windows, it's really convenient because you can just mount the VHD file. What we'll see here is, hey, it's a standard Windows hard drive. We'll open up the Windows folder. Cool. So from there, we want to get the local admin credentials. So we're going to use Cain enable to pull up the system and SAM files. If anybody's familiar with this, they've probably done this a few times. But basically, we're going to grab the local cred store off of that Windows hard drive, along with the boot key for it to decrypt it. and pull back the local administrator credentials. So in this case, we're going to get the NTLM hash for, it'll show up in a second, the AZ administrator account. We see the NT hash on the right there. So there's a couple of different things we can do at this point. We go ahead and crack it, throw it into Hashcat. We crack that one. It's AZ-admin pass with an exclamation mark. Okay. I'm kind of making it easy on myself because I created that password. But anyways, if that's the situation we're able to crack that, we could just go ahead and load up that virtual hard disk in Hyper-V and log in ourselves. So we can see here with a nice little who am I down here, we're logged in as that user, loaded this up in the Hyper-V manager, and now we've got full access to that virtual hard drive. Cool. There's lots of other things that you can do with full access to that. You can just browse the files and look for things. What's nice about this is once you've got full local admin access, you can start using any applications that are on there. So if it's a virtual machine that's used to run a client application or something like that, you might be able to do the same things that you'd be able to do up in the cloud down on your local desktop. So that's convenient, but we kind of want to pivot up into the Azure environment at that point. So let's say that we knew a little bit more about the environment. We knew the endpoint that the VM was pulled from. If we have the IP address for it or host name, we could potentially find that out on the internet and RDP to it. There's a surprising number of Azure virtual machines with management ports wide open to the internet. It's one of the default options that you can select when you create the virtual machine. Just say, yeah, I want RDP open to the world. It warns you. It says, hey, you're setting up RDP open to the world. You may not want to do this, but it's something that's pretty easy to set up. So let's say RDP is open. We'll just go ahead and log in. Ran Mimikatz. Hey, we got access to a domain user for the Fosaaen domain. Previously, we just had local admin rights. Now we're getting into the actual domain here. So in this case, ktest is a domain admin. Like I said, I'm kind of stacking the deck here because this is my demo and it's easier to demo this stuff. This is based off of real world experience. We've actually had experiences like this where this has worked. But let's say that RDP is not open everywhere. Well, we can go ahead and grab the SAM, security, and system files and use the Impacket secrets dump to go ahead and get the cached credentials. So we can see here that ktest account on the Fosaaen.com domain. We've got cached credentials here. So this happened when that domain admin logged into the box and that was cached on the Windows system. So we pull that cached credential out and we go ahead and try and crack that. So in this case, I created this user as a domain admin in Azure Active Directory. If you drop off all of the exclamation marks, that's the password that Microsoft created for that user by default. By default, in Azure Active Directory, if you let Microsoft manage that domain, it will create an 8-character password right off the bat. It's upper, lower, alphanumeric for the first 4, and then just numbers for the last 4. So like Karl 1234 might be an actual password there. This is the password they gave me. I put a couple exclamation marks on it because I needed to reset it a couple of times. But in this case, we're able to get the cache credential, crack that. Now we've got domain credentials that we can then go log back into the Azure portal or log in through PowerShell and start dumping information. So with domain credentials, we'll go ahead and connect the Azure RM account. This is just more of the manual process of adding that account locally. If you're running any of the MicroBurst tools, it will prompt you if you're not already authenticated. But for proof of concept here, I wanted to show you that process. This is the ADAL login process here. Just put in the ktest@fosaaen.com and the password we had. Hey, we're logged into MicroBurst demo. Cool. So what we're going to do here is dump the Azure domain info. So we're going to select our subscription here and start dumping out all of these services and information. So this specific script here is going to go through the subscription and dump out all of the users, all of the groups, all of the services that are available, basically general configuration information so you can get all of the information about what your attack surface area is. I kind of left some of the password stuff out of here and kept that in the get passwords because wanted to separate the two in case you wanted to use this for more audit focus compared to pen test focus. If you're doing more of an audit of your environment, you probably don't want to dump all your passwords into the config data that you're also dumping here. So I will say that this does run a little bit slow on larger environments. If you're looking at 10,000 users in an Active Directory domain, this could take quite a while to enumerate all of the users and groups, because it'll go through every one of the groups and get each of the users for each group. So there are flags on here to disable that. Here we're showing the output here. So it's going to output to text files and CSV files for easy parsing and easy data management. But I will say, if you're dealing with a very large environment, I would recommend just disabling the users and groups, because that might take quite a while. So next thing that we're going to do here is, get the Azure passwords. So we can see here that we're logged in as ktest and running the get Azure passwords function within here. With this one, I definitely recommend outputting to grid view. So you'll see the grid view output at the end of this, but grid view is that nice, well, grid view. But it's a nice way of visualizing some of the data, and it makes it easy for sorting and copying things out. So we can see here, it's grabbing the list of key vaults, the Azure App Services, and running our randomly named PS1 file here. And here's the out grid view. So like I said, this is really handy, and like I also said, I've burned down this entire environment, so none of these passwords are going to work now. So it's okay if you guys see these. But what we can see here is, there's a number of different credentials here. The Azure automation account, we've got some app service configs, a secret up at the top with super secret value. So there's lots of good information that you can actually pull out of these. But like I said, key vaults are usually a little bit more locked down, so your mileage may vary there. All right, so last item that we're going to cover here in the demos is code execution. Now this is relatively new. I'm going to actually push the code for this within the next week or so here. I'm just making some kind of last minute tweaks to the code and for the blog post that's going to go with this. But this is a way to execute commands on all Azure virtual machines, which might be kind of handy. You can also limit it to individual subscriptions or individual resource groups, or just a list of Azure virtual machines that you want to provide. But Azure is nice enough to include an invoke Azure RM VM run command. So it's a bit of a mouthful here, but basically you can point the Azure RM VM run command at a specific virtual machine and say, hey, run this PowerShell script, and it will do that. It does require contributor rights, so somebody that has a little bit more access than a regular reader user. However, what we've been finding is development people will typically have contributor rights in the Azure environment because they need to spin up virtual machines, they need to deploy code. They typically have a little bit more access. So if you get access to a developer account, chances are you're going to have contributor rights. So the really nice thing about this is all of the commands actually execute as NT authority system. This is really bad. This is the most privileged you can get on a virtual machine in Azure here. You're running as system, you're running as the operating system. It's great for us because if we want to run Mimikatz against all of the virtual machines, it's pretty easy for us to do that because we're already system. So in the demo we're going to show actually running Mimikatz here. But so some practical uses here, running Mimikatz against all the virtual machines to gather all of the available clear text credentials or MTLM hashes, pulling those off of those boxes. Potentially tasking C2 agents, so if you want to get, say, an Empire or Meterpreter shell on all of the virtual machines in the Azure virtual machine environment, you can go ahead and just do that. You basically just task it up and say, run this PowerShell command and hit go. Searching for data, that's kind of nice. You could search for sensitive files on stuff. Not so practical uses, setting up botnets or crypto miners or deleting everything off the virtual machines. Don't do those things, those are bad. That's my disclaimer for all of this. Just be careful, don't do bad things. This also, your success may depend on the VM region or the virtual machine configuration. I've had some different regions that don't respond all that well to actually tasking up these commands. Currently, the thing that's kind of delaying the blog post is I'm going through each of the different Azure virtual machine regions that you can deploy to try and get kind of timestamps on how long some of these commands run. A standard US West virtual machine, running it from my internet connection at home maybe takes 30 seconds to a minute to execute the Mimikatz PowerShell script. But what you have to think about is we're actually uploading the entirety of that Mimikatz PowerShell script to that virtual machine, running it, and then pulling the info back down. So it does take a little while to travel over the internet. If you're going, down to Australia or something, that's got a bit of a round trip to make to get back to the US. So that could take upwards of a minute or more to actually execute. Conveniently for our demo, I'm able to speed up time in video, so it doesn't take that long. So what we'll do here, and what you can see on the screen right now, is we'll run the invoke Azure RM VM bulk CMD with the Mimi test PS1 script, and then we'll jump right past our video. Using the verbose script tag here, we can see the IP addresses for that virtual machine. This is kind of handy for just keeping tabs on where that's actually running. And we can see the Mimikatz output came back. And it'll get to our password here. Hey, hello BSides PDX. So what's really nice about this is, if you're using that verbose and you're tasking, say, Empire agents to phone home, you can then correlate the specific external IP addresses that are coming back, or internal ones, to the verbose logs here, and kind of figure out which systems actually executed your command and control, all of that. So that's the end of the demo here. Talking about fixes and kind of conclusions here. In general, try to limit your Azure access for non-admin users. There are options to do that and get that set up. We do see it occasionally in some environments. One thing that I didn't note in here is that we've actually had web applications that have allowed for Azure Active Directory portal access. So we've logged in with an application services application that uses Azure AD for authentication, or handling authentication for users. And we're actually able to use those credentials to log into the Azure portal. So something to keep in mind as you're developing applications in Azure. If you're using Azure Active Directory, make sure you're locking down access for that. One that's going to be really hard here is try to get users to stop using fall 2018 as a password, or season year combinations. I don't mean to call out or shame anybody here that is using that, but that is the first thing we're going to guess on a pen test. Season year combination is one of the most common that we run into outside of like company name 1 or password 1, things like that. It typically meets complexity requirements. We've got 8 characters, upper, lower, and a number here. That's going to get us access. Set up multi-factor authentication for Azure access. This is actually really easy to do. I did this on my demo environment in like 3 minutes, so it's really simple to set up. Conclusions-wise, PowerPoint's a major pain. The cloud is complicated. Misconfigurations will happen. I learned a lot about configuring cloud services while putting this together. I mess stuff up myself, sometimes intentionally, sometimes not intentionally. But there are options for mitigating the risks. We've got the MicroBurst tool set that you can use to check your environment. There's other tool sets out there as well. I know that some of the automated vulnerability scanners out there now do some configuration reviews. I know Tenable's got some profiles you can use for that as well. So there are some options out there. Any questions? Yep.
So assuming you're using this for benign purposes, you've got a corporate bank account behind you for this pen test, would it be more expedient to spin up a storage container in the same region as whatever you're pen testing for, like your cloud region or your file stores or your blob stores, and then make those copies directly in region to something that you own, you possess, and you can analyze at your leisure?
You could potentially do that. So the question was, when you're doing a pen test and you've got some additional resources to spin up potentially, would it make more sense to use a more localized resource to copy over some of like VHD files or really large files? I haven't tried that personally. Probably saves a lot of time. I've been looking at different options. I'm actually working with somebody online who's working on some other stuff kind of similar to that. But in terms of trying to parse those files, fully downloading like a 120 gig image takes a long time. Yeah. Other questions?
It's great, the pen testing. I'm on the auditing side, and I think of like, have you thought of like a policy base? And I think I heard you mention at the end, like basically cloud governance. So, like enforcing defaults if they're not correct, basically, and that kind of stuff. Basically writing.
Yep. So the question was not only looking for kind of out of policy items, but actually enforcing those out of policy items. I don't have anything in here at the moment to do any of that. We're trying to make this read-only kind of testing. There's some stuff that does make some changes, but we try to avoid major state changes in general, just as kind of a rule of thumb. But in terms of a tool that could automate that, that would be pretty handy for people to use, or at least prompt them before they make the changes. Any other questions?
How noisy is MicroBurst, and what tools might a blue team use to detect its activity?
So that's a good question. The question was, how noisy is MicroBurst and how likely would a blue team detect this? So the nice thing from an attacker, red teamer's perspective, is we're using native technologies with the Azure Commandlets, so it's kind of expected behavior to a certain degree. There are some indicators for the invoke remote command. So I have that in the blog post that's coming up here. You can set up specific alerts for specific items, particularly around the command execution. If you're allowing people with contributor rights to run system level code on your virtual machines, you should definitely be auditing that. And I'll have specific instructions in the blog post about that.
There should be very specific logging on the key vault as well.
Okay, yeah, the note.
From user done.
Perfect. So the note from the crowd here was that there should be very specific logging for the key vaults, and I've looked into that. Yeah, I haven't done as much on the logging and blue team side of things. I've mostly just been trying to write tools to attack, but eventually we'll switch over to more of those. Any other questions? Nope. All right, cool. Well, thanks everybody for coming out for a Saturday afternoon talk. Like I said, I know there's competition with the anime and Pokemon here, but thanks to my NetSpy coworkers who did a lot of the QA on this and helped with testing, and anybody watching online, thank you.